No, that's okay. Don't worry about it. You can watch it in class, or you can catch up and watch it later. No big deal. Don't worry about it. Hey guys, Mr. Shaw here. We're going to be talking about, we're going to get into Chapter 3, Solving Systems by Graphing. Really the whole chapter is just about systems of equations. And this video in particular is going to be pretty notes heavy. We're going to try to get most of the notes out of the way in this one, and then we'll kind of get more into, the actual process behind all this stuff afterwards. Anyway, let's go ahead and jump right in. So the first thing is vocabulary, okay, as always. Now again, the thing you're going to need to worry about with vocabulary, so a system is going to be, it's going to be two equations, okay? I should say two or more, wow, okay, sorry, I can't spell. Okay, two or more equations. All right, and that again, and what we're gonna do is basically they're gonna convert, or they're gonna converge at a single point. Okay, and that is going to be our answer. Okay, now again, they're not always going to converge at a point, but again, if they do, it's a consistent system. So we'll say this one will have let's say one solution, or a solution, or a solution. Okay, an independent system those are parallel lines like that. Okay, so that would be no solution. And a dependent system is going to look like this. Let me change colors here. Something like this. Yeah. Okay. You see that they are overlapping. They would share every point. Okay. Again, is a dependent system. Okay. So anyway, those are again I'm sorry. The answer here for this one would be infinitely many solutions. All right, that's it. That is it for vocabulary. All right, so let's get into the notes. Again, guys, I'm gonna go through. I'm gonna kind of talk about it, then I'm gonna go on. If you need more time to write it down, just pause the video. All right, so again, like I said, a system of equations is two or more equations with the same variables. Most of the time, you'll see them with x and y. Sometimes it'll be like a and b to throw you off, but most of the time, it's just x and y. And we've got three methods. Okay, we've got graphing, substitution, and elimination. Today, we're going to be talking just about graphing. And the last thing is that the solution of a system is an ordered pair. Okay, and you have to write it as an ordered pair because it's actually the solution is telling us where they cross. So where the lines cross. It doesn't have to be lines, okay, but where the equations cross, something like that. All right, and again, what you're going to do is it has to satisfy each equation. So in order to check your answer, you're going to plug it back in to make sure it works. All right, so again, this is just kind of getting more into what I was talking about in the vocab section. We've got three possible solutions to these linear equations. Again, if you have one solution, it's going to look like this, just where they're crossing once, one intersecting point. No solution, where they have their parallel lines, just like that. And then an infinite number of solutions when they're overlapping, they're coinciding lines. Okay, they're going to share every point on that line. Okay, make sure you graph these as well if you didn't get them down for the vocab. Okay, so now in this one, I'm gonna go through all the different types of solutions, and I'm gonna go back to the last slide to kind of get you an idea of what those are gonna look like. Okay, so if a system has a solution, okay, any solution at all, okay, it's considered consistent. Okay, meaning that they intersect. So including when they're like overlapping. Okay, that means that they are intersecting, okay, but they intersect at every point. So that is a consistent system. Okay, if a system has no solution, it is considered inconsistent, okay, meaning that the graphs are parallel. If a system has exactly one solution, meaning they are only intersecting at one point, okay, it is independent. Okay, so again, just one point. This would be an example of an independent system. And then, again, these are like separated. Again, these are not exactly, these cover different things. Okay? I guess I should have done it this way. Oh well, it doesn't matter. Okay. Then if a system, okay, so if it's one solution, it's independent. If it has an infinite number of solutions, the graphs, meaning the graphs are the same line, then it's dependent. So again, that's like in this case, they're sharing every point on the line. Okay, that is an example of a dependent system. All right, so let's go back for a second. Okay, I'm going to go back to this guy, and we're going to kind of figure out which one is which. So in this case, the one solution, you would call this consistent and independent. Independent. Got it. And then the parallel lines, again, this one is just going to be inconsistent. I don't know why my ends are looking so weird now. All right, inconsistent. And then infinite number of solutions, you would say consistent, but dependent. All right. All right, so just one. I think we've got just one more thing. I'm gonna go to the steps for solving these systems by graphing, and it's real straightforward. It just says graph the line from the first equation, then graph the line from the second equation, and then find the points that they intersect. That is so complicated. Good luck. I don't know how you guys are gonna make it through. All right, let's get to it. First one. Okay, guys, make sure it's so important that you're graphing these. Okay, make sure you guys are writing down the problems and graphing them as well. Okay, so here we go. For the first one, okay, we're going to start at positive 2. All right, and then our slope is negative 3 over 1. So we're going to go down 1, 2, 3, and over 1. Down 1, 2, 3, over 1. Oh, there go my lights. All right, and I'll do my best to draw that line. Again, I do not have a ruler here, so just... Again, yours should be better than mine. All right, now next one is start at negative 3. So 1, 2, 3. I'll do this one in blue so you guys can see the difference. So 3 here. And I go down 1 and over 2. All right, and then I draw my line. And you guys can see that they intersect right here. So this point is 1, 2. So 2, comma, 1, 2, 3, 4, so 2, negative 4 is my answer. And that's it. Let's keep going. All right, first one. This one that you see is actually not in slope-intercept form. I will graph this using intercepts, though, because we can figure that out nice and easy using the cover-up method. Okay, so if I cross this guy out, if I plug in 0 for y and I plug in x divided by 2, that'll be x equals 4. So 4 comma 0, 1, 2, 3, 4, right there. And then if I cover again, so I erased everything, and if I cover up the x this time, so plug in 0 for x, divide each side by negative 4, and then y will equal negative 2. So down 2 right here. All right, and then I can draw my line, my terrible line. That was bad. I can do better. Let's try again. That was better. Okay. Here we go, and now we'll do the other one in blue. So it's down 3. All right, and then I'm going to go up 2. So up 1, 2, and over 1, 2, 3. So right here. All right, and then it looks like, well, the way I graphed it, it looks like they cross right at 4 comma 0. So, okay, there you go, right there. So 4 comma 0 will be our answer for this one. And if you ever are curious and you want to check and make sure that it actually is in the right spot, that they cross in the right spot, you can actually just set them equal to each other and then go through that. Like if, for example, I can plug, what we'll learn in the next video is that you can take this and you can plug it in for y, and then you should get out the same, like this, you'll be able to figure out what the solutions are. Anyway, I'm getting ahead of myself. So don't worry about that. For now, we'll just worry about getting the solution. All right, let's keep going. We got 2 more. All right, so first one, again, I'm going to go ahead and get this in. I'm going to solve for y on both of these. Again, they're not in slope intercepts, so I'm going to go ahead and do that. So subtract x from both sides. So y equals negative x plus 7. So start at positive 7, 1, 2, 3, 4, 5, 6, 7. Go down 1 over 1, down 1 over 1. So here is our line. Something like that. Man, that was bad. My goodness, guys, I am so sorry. All right. And then the last one, again, here I'll do this one in blue. So subtract 2x from both sides. So 2y equals negative 2x plus 4, and divide by 2. So y equals negative x plus 2. So you guys can see that they have the same slope and different y-intercepts. So in this case, it actually means that they are going to be parallel. Now, a couple of things that I want to say as far as the answer to this problem goes. Oh my goodness. Okay, hang on. It erased. I hate it when it erases itself. Okay, there we go. I'll draw it again just to make sure. Okay, so, and then in this case, the answer, again, you see they don't ever cross, so the answer is no solution. Okay, we'll also say that it is an inconsistent system. And they're also parallel lines. So just three things, three words that you guys need to know. Make sure you guys are just paying attention to that, because again, I will want you to be able to tell me what all three of these mean. Okay. So anyway, last one. So we can go ahead and graph the top one. Okay, that one's already ready to go for us. So it's down 2, up 3 over 1. So here's my line. And for this next one, I'll do this one in green. So I'll solve for this one to slope-intercept form. So subtract 6x from both sides. So negative 2y equals negative 6x plus 4. And last step is to divide by negative 2. So y equals positive 3x minus 2. Now again, you'll notice, same thing. So again, I'll just, plot them over each other just so you can see that they are the exact same line. Just like that. And so again, the terminology that you guys need to know for this one, again, what you're going to say is you're going to want to say that the answer, there are infinitely many solutions. Okay, you want to say that it is a consistent and a dependent system. And then they are the same line. Again, you just need to know that this sort of solution has to do with all of these different words here. All right. Okay, guys, I'm done. Hopefully that was a good introduction for you. And if you guys have any questions, let me know. And hey, thanks for watching. I don't have to listen to the Backstreet Boys now. I appreciate that. See you guys.